How's it going, ladies and gentlemen? It is Mr. Donahue here again. This time taking a look at 1.6 dimensional analysis and basically how to avoid working with a bunch of ugly numbers when you're doing math. Alright, so objectives of this video will be to perform dimensional analysis using conversion factors while accounting for uncertainty. So, question, how many centimeters are in 0.72 miles? Well, you may be thinking, I know how to do this. I can convert miles into feet, and I'm going to use my conversion factor of 5,280 feet per mile. So I'm going to do 0.72 times 5,280 feet per mile, and I'm going to get 3,801.6 feet, right? And now I know I'll write that number down, this big ugly number, and then I'll go, all right, I know how to do feet to inches. I can times my feet by 12 inches in a foot, and I end up with 45,619.2 inches, another big ugly number. And then I'm going to times that by centimeters. To get centimeters, I'm going to get, 2.54 centimeters in an inch, and I'm going to get what? 115,872.76 centimeters, which I think, my calculator can't fit any more digits. There might be numbers even after that. I'm not sure. So how many of you would do it this way and write down the numbers each and every step? It's obnoxious. Don't do it. There's a better way. All right, there's a much better way. Dimensional analysis. So basically, we're going to take a systematic approach. And we're going to set up all the math, and then we're only going to pick up the calculator once. So that's our goal, is to only have to pick up the calculator once, and then we get our answer. And we're going to round at the end. We're going to save all our rounding for the very end. So how many centimeters in 0.72 miles? Well, dimensional analysis, it would look like this. We'd have 0.72 miles times 5,280 feet per mile, so the miles will cancel out. This way I know what I'm doing with my units, and I'm doing it right. Then I'm going to times it by 12 inches in a foot. The feet cancel out, and then I go, all right, well, I'm times that by 2.54 centimeters in an inch. Inches cancel out, and then I'm going to get my answer. So now I can just pick up my calculator once. I know it's going to be 0.72 times 5,280 divided by 1 times 12 divided by 1 times 2.54 divided by 1. And then I'm going to get an answer, right? So how do I approach these problems? Well, ask yourself a few questions. One, where do I want to end up? What am I being asked to solve for? What is the question asking you to get? Two, where am I now? What do they give me? What information did they give you? And step three, how can I get from where I am to where I want to be? Are there equations that I know, conversion factors that I'm going to need? Stuff like that. And here's a tip. When you start with linked units, like for example, grams per milliliter, put whichever thing you're trying to solve for on top and start with that. So for example, 2.94 grams per milliliter. If I needed to solve for milliliters, then I put 1 milliliter on top over 2.94 grams, right? It'd be 1 milliliter over 2.94 grams. That's the same thing as this, just flipped. So let's take a look at this example. It says the output of a plant is, like a production plant, is 4,435 pounds of ball bearings per week, which a work week being 5 days. It says if each ball bearing weighs 0.0113 grams, how many ball bearings does the plant make in a single day? So first question, where do I want to be? Well, they're asking me to get ball bearings per day. Where am I now? Well, they also tell me that I got pounds per week. They tell me 4,435 pounds per week. And what do I know? Well, I know a bunch of things. I know that 5 days is 1 week. I know that each BB is 0.0113 grams. And I know that there's 454 grams per pound. So I'm going to start with what I know. All right, so I have 4,435 pounds per week. And I know that I'm going to start with the pounds up top because it wants quantity, right? How many ball bearings does the plant make in a single day? That's per day. So I want the time on the bottom and the amount on top. So I got 4,435 pounds in a week. Well, how do I go from pounds to grams, and how do I go from weeks to days? Well, I can start with the weeks to days. I know that 1 week is 5 days. And which one do I put on top? Well, I put the week on top so that the week cancels out right there. So now I'm left with pounds over days. Now I need to convert grams to pounds. Well, I know that 1 pound is 454 grams. Now my pounds cancel out. And now I go, all right, well, now that I know grams, I can convert grams to BBs because I know how much each BB weighs. So I know that 1 BB is 0.0113 grams. The grams cancel out. Now the units that I'm left with are BBs and days. So now I can pick up my calculator and do all the math. I'm going to do 4435 divided by 1 times by 1 divided by 5 times by 454 divided by 1 times by 1 divided by 0.0113. And I'm going to pick it up once, and I'm going to plug it all in. And now I'm going to get an unrounded answer of this huge, ugly thing, which I can't draw straight lines. So, boom, that many BBs per day. Well, now I got to round. I got to look at my numbers here. I know that the 4435 pounds has 4 sig figs. I know that the 1 week to 5 days is an exact number, so I can ignore that. I know that the 454 grams per pound is really 3 sig figs. That's not an exact number. I rounded off. I used 454. I could be more precise, but I wasn't, so it's only 3 sig figs there. And then this 0.0013 grams also only has 3 sig figs. So now I'm going to look at my unrounded answer and round it to just 3 sig figs. So I count from the leftward side, 1, 2, 3. I look over. There's a 3 there, so that 6 is going to stay 6. So it's going to round to 3, 5, 6, and the rest of those numbers are going to become placeholder zeros. So we get 3, 5, 6, 0, 0, 0, 0, 0 BBs per day, or in scientific notation, 3.56 times 10 to the 7 BBs or ball bearings per day. So that's how you'll do it doing dimensional analysis. Here's another example. If a snail crawls at 0.029 miles per hour, how many days would it take a snail to complete a marathon, which is 26.2 miles? So again, first question, where do I want to be? I want to end up with days. Where am I now? I got miles per hour. And what do I know? Well, I know that I have to go 26.2 miles total, and I know that there are 24 hours in a day, right? So that's where I'm going to start. Now the question is, well, if I'm being asked to solve for time, and the thing that I'm starting with is 0.029 miles per hour, and time is on the bottom, I'm going to want to flip that so that the time is on top. So I'm going to start with 1 hour, the snail goes 0.029 miles. Instead of putting miles on top and hours on the bottom, I'm flipping them around because I want to end up with time. So I'm going to start with time on top, so I don't end up with, instead of days, I end up with 1 over days. I don't want that. So I flip it. So now I go, all right, well, how many miles do I got to go? Oh, well, let me start with hours. I got to convert hours into days. So I do 1 day is 24 hours. I got to put the hours on the bottom so that the hours cancel out. And then I can do my miles. Now I got 26.2 miles. I'm going to put miles on top so it cancels out with miles on the bottom from what I start with. And that's for 1 marathon. And what do I get? Well, I plug in my calculator. I get an unrounded answer of all this. And now I got to round my answer. Well, I got 2 sig figs and my 0.29. I got, well, this is an exact number. 1 day is defined as 24 hours. And then I got 26.2 miles in a marathon, which I'm pretty sure is also an exact thing. They're saying it's exactly 26.2 miles. So I got to round to 2 sig figs. So I go, all right, well, 1, 2. My ones place is my precision. I'm going to look over. There's a 6. It's going to round up. So the answer is 38 days. So if you think you're going at a snail's pace, I highly doubt it. All right, so summarize. What can you say about how to carry out dimensional analysis? How do you do these problems? And that's pretty much it. So I hope you found that helpful. I'll see you in class. Okay, bye.